Does the CCNA switching routing the protocols wherever advanced?
Advanced.
Advanced.
Okay. So today we're gonna see one layer 3 security protocol that is nothing but ACL. Okay. Access control list. The name itself will tell you it's kind of a list, okay, where you are going to control the access of some devices with the help of the layer 3 device. Okay. It's majorly configured with the routers. It's configured on what? Router devices. You can see here ACL. It's a mechanism which allows or denies the traffic based on a set of predefined rules. So these rules specify the conditions such as IP address or protocols or port numbers that control whether traffic is permitted or blocked. So what will happen here with the help of some list? Okay. So we're gonna give some list or policies, I can say. Okay, so based on these policies or list, what we're gonna do, either we're gonna admit the traffic or else we're gonna deny the traffic. Okay, so this is what we're gonna do here with the help of this ACL. And this is also called as what? Packet filtering protocol, because it's gonna use what? These packets, IP addresses or protocols or port numbers. Okay, so based on this one, it's gonna permit or block the traffic here on the router. You can see here it is a layer 3 security protocol which controls the flow of traffic from one router to another router. Okay, so how exactly this works here? You can see the first one, packet filtering. Like ACLs examine each and every packet which is incoming or outgoing, and it's going to compare those packets against whatever the rules you are given. Okay, so if the rules are predefined rules you are given, okay, so those predefined rules are matching there, then it's gonna either it's permit, it's gonna deny it or drop the packet there only. Okay, so this is why you use what? ACL. Okay, so as I said you, it's gonna either permit the traffic or else gonna deny the traffic. So based on the conditions in the rules, packets are either permitted, that means allowed to pass, or denied, that is totally blocked on that particular interface. Okay, it may be incoming. Incoming means what? Getting inside the router, or outgoing, getting outside of the router. Okay, but the thing is, like, whenever you write the rules, there is order. What is that order? ACL rules are processed in a sequential order. If a packet matches a rule, then subsequent rules are not evaluated. Okay, you can see here, whenever you are writing any rules, you should be very cautious. Why? Because you can't give permit initially. You can't give permit initially. Why? Because initially permitting the traffic, then it is not going to go for the subsequent rules what you're given. Okay, so that is the reason whenever you are writing the rules in the ACL, first always give the deny rules first, and then at the end you can give the permit rule. Okay, this is what the rule you have to follow whenever you're writing what? ACL rules. Okay, why? Because if the traffic is getting permitted here, then it's not going to go for the next one, whether it may be any permit or it may be any deny. Yes, so the permit is allowing any traffic where it is, whatever the rule it is given here in this traffic, so that's gonna allow that one. So that's what I said, it's not going to check for what the next rules what you have given there. Okay, so one thing is really important, implicit deny. Okay, what is this implicit deny? uh yeah, here it is. An implicit deny blocks all the traffic by default when there is no match, or so it is an invisible statement. What do you mean by this one? At the end of every ACL, there is a implicit deny all rule. What do you mean by this one? If any of the rules are not getting matched, then it's not going to wait for, it's not going to allow any kind of data. Okay. If I say that deny, 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 and at the end I'm not giving any permit rule, then what it's gonna permit? You said everything deny, what I have to permit? It will ask you like what I have to permit. Yes, so that is the reason it is totally just dropping all the traffic which is coming or going outside of the router. Okay, that is called as what? Implicit deny. Yes, so this means any traffic not explicitly allowed is totally denied. So that is the reason you have to give at least one permit, at least. Okay. So in this one, we have some two types. The ACL, we have two types. Mainly, we have numbered ACL and named ACL. You can say it either way, okay? Because we have two more types of this one. In here also we can make it to like a standard or a extended ACL, and here also we can have the same standard and the extended. Okay, if somebody asks you what is the type of ACL, you may say it like what? Standard ACL and extended ACL in both named and number. Okay, or else you can say numbered and named ACL in both standard and extended. Okay, so in that first one, we're going to see the numbered ACL. So you can see standard ACL, it can be both named and number ACL. So the access list number range is between 1 to 99. So what is the ACL number for standard? The total is like 1 to 199. So this is a number range what we use for total ACL. So out of this, what we use 1 to 99 is used for the standard ACL. Okay, and remaining 100 to 199, it is used for what? Extended ACL. I mean, whenever you're creating the ACL, it will ask you for a number. So based on that number, it's gonna understand that, yeah, this is a standard ACL and this is a extended ACL. Okay, and even the features will also be changes whenever it comes to standard and extended. Okay, that's the same we will discuss here. So in a standard ACL, we can deny or allow a network, host, or a subnet also. What do you mean by this one? What do you mean by a network or a host or a subnet? What do you mean by this one? Anybody? Give me an example for network. Yeah, any network. 192.168.1.0, it's a network. And host means what? 192.168.1.1 with a slash value 24. Okay. And subnet means what? 192.168.1.1 with a slash value 1.0, the slash value, you can take 26. Okay. So this is what the network, whole network, and one particular host and one particular subnet. Okay. So this will allow or deny both. Both means what? Sorry, all these three. Network, the whole network, or one particular host out of that network, or subnet of that particular network. Okay. So here filtering is done on the basis of source IP address only. Just remember, in the named standard ACL, sorry, numbered standard ACL, it will just check what? Source IP address, nothing else. So here the filtering is totally done on the basis of what? Source IP address only. Yes, and it cannot identify the services, so all the services are blocked here. So what kind of service it is having? You can see here FTP, HTTP, HTTPS, and other things like. Okay, I hope you know that in some of the companies, the Facebook will be banned and the Instagram will be banned just to browse that one on the Google. So how they do that one? With the help of this extended ACL and all, or with the help of firewalls. Okay, if you are giving any request in the form of HTTP or HTTPS, okay, what it will do? Already HTTP and HTTPS, this kind of a, what do you call them? request will be already denied there. So that is the reason you will not be able to browse those kind of things. So that will be done with the help of this ACL or a policy is what they give on the firewalls and all. Okay. So here the standard ACL doesn't support any kind of services. Okay, because it can only understand what? Source IP addresses. So based on the source IP address, it's gonna filter out all the data. Okay. So that is the reason by default all the services will be blocked here. And it is implemented closest to the destination. This is very important. When you are implementing this one, okay, where we have to implement this one, that you should know. Whenever it comes to standard or a numbered standard ACL, you have to understand that it should be implemented closest to the destination. Remember, keep it in your mind. So that's what about the standard ACL. Next is the extended ACL. So it can be both number or named ACL. So the access list number range is 100 to 199. What was the number of the standard ACL? 1 to 99, and the standard ACL is what? 100 to 199. And here we can allow or deny again the network, host or subnet, and even the services like what? FTP, HTTP, HTTPS, and all the DNS, DSP, all these kind of things will be allowed or denied. Okay, with the help of protocol number or a port numbers. So this extended ACL can understand all IP address, protocol number, and port number, and everything. So based on that, it is going to control the traffic. But what the standard numbered ACL will do? It can only understand IP address. That too, source IP address. Okay. So here filtering will be done on the basis of what? Source IP address, destination IP address, protocol, and the port numbers. Okay. So this is a extended version or an extra feature what we have in the extended ACL as compared to the standard. Okay. And whenever you are implementing this one, where you have to do that? You have to do or you have to implement near to the or closest to the source device. Okay. Standard ACL near to the destination, and the extended will be done in the source device. So whenever you are writing some rules here, okay, you have to follow these rules. What are those? The first thing is what? As I already said you, it works in a sequential order. It is not like first it will check the first rule and it's going to jump for the third rule and then sixth rule. No. First it will check for the first rule. If it is permitting, then it's not going to go for the next rules. Okay. So here it says deny. Then it checks that yeah, I have to deny. I'll just deny this. Okay. Then what I have to permit? What I said first, the first thing you can see here, all deny statements have to be given first. Okay. First, it will check forward all the rules in a sequential order. First, what it will say? Deny. Okay. If I'm denying this one, then what I have to permit? So at the second also I have to deny. So the same. If I'm denying here, what I have to permit? So deny. Okay. So at the last, what I said, there should be at least one permit statement, and that is what? It's mandatory. It's mandatory to have what? One permit list, one permit rule at least. Okay. Otherwise, it will go into implicit deny. As I already said to you, if any of the rules are not getting matched, then it's going to drop the whole traffic which is coming or going outside the network. Okay. You can see here, an implicit deny blocks all the traffic by default when there is no match. So it is an inevitable statement. Yeah, you can't say this one, but it will be working behind. Yes. And it can have one access list per interface per direction. Means two access lists per interface, and one in a inbound direction and one in a outbound direction. Okay. So just see this one. This is my router. Okay. So it is having two interfaces. Yes. And if I'm sending any traffic from this end to other end, so this is my one more router. Okay. So if I say, it's a PC, okay. If I say ping 20.1.1.1, okay. So 20.1.1.1 is here. Understood? So here obviously 30 and here it is 10 network. Okay. When I said ping 20.1.1.1, so obviously it is going towards the router, right? Yes. So this is called as what? Inbound traffic. Okay. Where it is called? Inbound traffic, where it is getting inside the router. Okay. And whenever it wants to reach the 20.1.1.1, where it has to go? It has to go on this interface. And whenever it go outside of this network, this is called as what? Outbound. And that traffic will be inbound for the second router. And the same traffic goes towards the 20.1.1.1, that will be the outbound. So understanding this interface is also very important whenever you are what? Configuring the ACL. Okay, because on which interface you are denying or permitting the traffic, that is really important here. Yes. So if it is, if the 20.1.1 is replying back, then that traffic will be inbound to the router 2, and when it goes towards the router 1, that will be outbound. And when it enters this router 1, that is called as inbound, and when it go towards the 10.1.1.1, that is called as what? Outbound traffic. Clear? And on this one, on one particular interface, you can have two access lists. You can have two access lists, one for the inbound and one for the outbound. Okay, because as I already said you, one for the inbound. Okay, if you want to deny on that one, so that will be given on this interface as a outbound direction. Okay, so the same thing they said here, can have what? One access list per interface per direction. Per direction means what? Inbound, one access list, and outbound, one access list. Clear? Next is, anytime a new entry is added to the access list, it will be placed at the bottom of the list. So whenever you are writing the list here, the access list, if you given deny, okay, deny and permit. And if you think like, I forgot one more rule, okay, that is a deny rule. Okay, so if you think like it's gonna be in between this or before the permit, no. Whenever if you add any new rule inside the ACL or the same ACL, then it's not gonna be in the between of this deny, it's gonna be added at the end. So that is not of any use. Why? Why it is not of any use? Because already you are permitting the traffic here. You already said just deny this and deny this, and remaining all should be permitted. And there is no use of this deny rule. Okay. So it will be placed at the bottom of the list. So using some text editor and all, you have to remove the whole access list and you have to use this one. Okay. You have to configure again. Okay. And you cannot remove one line from the access list. What I said, if you want to remove this one, I don't want this rule. Okay, I want to remove only this one. No, it is not possible. You have to go to remove the whole access list only. Okay, only in numbered ACL. In named ACL, it is possible. In named ACL, it is possible. If you want to add a new in between the rules, yes, you can do. And if you want to remove one of it, okay, whatever the in between rule you have, you can do that. But it is not possible in the numbered ACL. Remember this one. Okay. So these were some rules just to write the ACL. So to write a ACL statement, we have to decide what? We have to decide these three things. One is on which router you have to implement. On which particular router you have to implement. If you are going for the standard ACL, you have to implement it on. You have to implement it on standard ACL, near to destination, and the extended ACL near to source device. So deciding that one is really important. And next, Identify which route, which is a source and which is a destination, the same. And then which is a ingress or egress, the same, inbound and outbound interface. So deciding this also is really important. Okay. You can see here, deciding in-out interface is very important. Like any packet going towards the router is called as what? In interface. And any packet leaving or going farther the outer router is called as what? Out interface. It's very simple. Going towards the, that's called inbound. Going outside of the router, that is called as what? Out interface or a egress. Yes. Mm, named ACL. Okay. Just decide and we'll directly go for the configuration. Yeah. The access list in the named ACL, access lists are identified using names rather than the numbers. Instead of giving 1 to 99 and 100 to 199, you will give a name here. Okay. By selecting whether it is standard or extended. I'll show you later. And here names are case sensitive. Okay. So if you are writing it as what? One access list as a Arun, and if you give the same access list as a small a, so both are different access list. They are not same. Even the word is same, but it is a case sensitive. Okay. So these are two access lists here. Okay. So no limitation of the numbers here. You can't limit any number here. You can give. Okay. With the name also, you can give the numbers. So here, one main advantage is what? Editing of the ACL is possible. The same thing I said you. What I said? Editing is possible in the named ACL, but it is not possible in the numbered ACL. You can see removing a specific statement from the ACL is possible. And if even if you want to add one more, you can add it. Okay, in the named ACL. Okay, so that is supported or allowed in the iOS version 11.2 or later. Okay, before that, we never used this named ACL. Okay, we used numbered ACL. Clear? Okay, let's go to the configuration where it is ACL. Yeah, I have already. Okay, because again, I have to do the routing and all. Yes, so I have already. So we just need to configure the ACL here. I'll just show you the configuration, the basic configuration, what I've done. So do I have any ACL? Yeah, I do have one. I'll remove that one. You can see I'm running with the RIP protocol. Okay, just for the routing purpose. Next, I'll remove this one. Config. No IP access list. What is that? Standard Cisco. One more is extended Cisco. I don't have any here, right? Yeah. Okay, good to go.
No, every thing to be aware of.
You want to? Are they? Online, am I audible clearly? Mr. Bosu, Kaitra, Pratik, Vaishnav, am I audible?
Yes, sir. Audible.
Yeah, here,
Yes, sir.
yeah, I've written standard ACL rules here. Okay, just few of that. So what I said, the 30.1.1.1 should not ping 10.1.1.1. So where is 30.1.1.1? Yeah. Okay. And where is 10.1.1.1? Yeah. Okay. So this two should not ping here. Yes. So on which router I have to implement this one? This one? Are you sure? Okay. 20.1.1.2 should not ping 30.1.1.2. On which router I have to implement this one? On router 3. Okay, let's do that. So first one, 30.1.1.1 should not ping 10.1.1.1. So you said like I have to do it on the destination, right? Okay. So how I have to start with that one? I have to say access list. If I say question mark, it will be giving you two options. What are those? One is standard and second is a extended. What's the number of both? Are they same? What I said? 1 to 99 is for the standard and 100 to 199 for extended. So just give it as a 1 for the what? Standard. If I say question mark again, it will ask me, you want to deny, you want to permit, or you just want to comment the access list here. Okay. Now what I said, first I have to give the deny statements. Okay. So just give it a deny. And if I say question mark, it will be giving me three options. What is that? Address to match. I mean the exact address, network address, and then any whatever the host you have and one particular single host address. Okay. Now I want to deny only one particular host. Which is that? Which is that? 30.1.1.1. Okay. So in that case, you have to say host. Understood? If it was the whole network, then you could have given directly one 30.0.0.0. Okay. But now I want to go with only one host. So that is the reason you have to give host 30.1.1.1. Okay. And if I say question mark again, nothing is there. So just say enter. I have given one deny rule here. Then next, after that, you have to give permit. So permit any other than this, whatever the traffic is coming is just a permit that one. That's it. Okay. Now tell me, I have to decide interface also. See, first thing what I said, we have to decide what on which router you have to implement this one. Yes, we decided and we even configured on the destination device as if because we are using the standard ACL here. Okay. And then after we are done with the source and destination also, and then we have to see egress or ingress also, right? Which is on which interface I have to do that one. Okay. So can you just tell me on which interface I have to deny this traffic? On 0/0 or 0/1? 0/1. Are you sure? Okay, let's suppose I connect one more router here. If you are denying the whole 30 network here also, here only, then is it going to reach the this next router also? No, right? Yes. What I said, what is the rule here? I just want it to stop only to ping what? 10.1.1.1. That's it. Okay. So here, if you are implementing on this interface, then it's not going to go for the next hop or a router what you're connecting. So that is the reason where you have to implement this one on 0.0, where only 10 network is connected. Understood? So deciding this also is really important. Yes. So it will be the out interface or interface. Inbound. See, let me tell you once again. I said 30.1.1.1 should not ping 10.1.1.1. So 30 dot is here. Okay, it will come here. It will be inbound for this third router. And on this interface, it will take outbound. And on this interface, it will take the the traffic as an inbound. Okay, it will jump here. This will be outbound for this one. And it will be inbound to the router one. And here, outbound. So this will be the out interface. We have to configure it as what? Out interface. Okay. I hope it is clear, everyone. Yes. So let's do that. On the 0/0, you have to say. So interface giga greater than 0/0, you have to say IP access group 1. It has to be out interface. Okay. If you say question mark, it will give you access group number. Okay. So whatever the number you are given, it may be standard or extended. You just give me the number where you want to add this into the access list. So I'll just give it as a 1. And if I say question mark, it will be asking you like whether it is an inbound packets or an outbound packet. So I'll make it as a outbound packet. Done. That's it. So let's go to the second one where I have to do that one. 20.1.1.2 should not ping 30.1.1.2. On which router? Third router. Okay. So config the access list 1 and next. What you have to give the deny and then one particular host. What is that? 20.1.1.2. Okay. And if I say question mark, nothing is there, just say enter. And one more we have to give, that is what? Permit. Any. Okay. That is it. Now tell me the interface. On which interface I have to implement this one? 0/1. Are you sure? As what? Sure. On interface we have done 0/1. You have to make it as what? Access group. Sorry. IP access group 1, and this should be out interface. That's it. Okay. And now we'll just check that one. So I'll just go on the second one and I'll try to ping 10.1.1.1. The command prompt and just say 10.1.1.1. So do you think it's gonna ping? Yes? Sure? Okay. No? It will. Okay. And if you ping 30.1.1.1, it will? Sure? It will ping. Why it is? Which host? Okay, let's check this 30.1.1.1. Okay, this one. So ping, sorry, 10.1.1.1. On 30.1.1.2, it is trying to ping. But whenever you go on this PC, where it is having 30.1.1.1, as I already said you in which one? In standard, it's going to look for what? Source IP address. What is the source IP address? 30.1.1.1. So this whole host address will be what do you call denied to reach each and the whole what do you call 10 network. Okay, if you check here the command prompt, if you say ping 10.1.1.2, do you think it's gonna ping 10.1.1.2? Are you sure it's gonna ping or no? It will ping? No, it will not. Why? Because as I already said you, it will only see what? Source IP address. It don't know, the standard don't know to whom to deny this one. Okay, if I'm having 10.1.1.1, sorry, 30.1.1.1 as a source, then I'm not going to allow you on 10 network, whole 10 network. Understood? But the thing is like, when I go on check it on the 30.1.1.2, it is pinging. Why? It's not matching with the source IP address. What is the source IP address I've given? 30.1.1.1, not the 30.1.1.2. So that is the reason it is able to ping with everyone. Okay. Is it? Okay. Even if you check with a 3, that will also ping. But when it comes to the 30.1.1.1, the whole 10 network will be denied on this one. This is denied. Why? Because it is getting dropped at the 40.1.1.1 only. Okay. Understood? Where it is getting dropped? Where is 40? On router first here. On router first 0/1, whatever the interface we have, here have configured with the 40.1.1.1. So this is where the traffic is getting dropped. Why? This router is not getting or allowing this traffic to get inside this one. Okay. And let's check the second one. 20.1.1.2 should not ping 30.1.1.2. So I think, sorry, 20, right? So here ping 30.1.1.1. Do you think it's gonna ping? Sure. Abhishek says no, because I'm having 20.1.1.2. So that's the reason the whole host is denied on the 30 network there. Okay. If you check with the 2, so there also it says that destination host is unreachable. But when it comes to the 10.1.1.1, there it will be reaching. Yes, only it is denied on the third router. Clear? Clear about the standard one? Yes?
10.1.1 will ping to 30.1.
10.1.1. No, it's not. It's not. So ping. In its gateway only. Okay. You want to check? Oh, it's at the other end. 50.1.1.2. Okay. Here it is. Drop it. Yes. Yeah. Any question in standard one? Sure. Why? What you learned here? Here, the standard ACL, it's only gonna see what? Source IP address. And based on that, it's gonna drop all the packets, whether it is denied or a alert. So it's gonna perform that one. Yes. Next, we'll go for the extended ACL. So before that, let me remove this. No access list 1, and on the third one, paste. No access list 1, done. Okay. Yeah. Did I configure anything on the second one? All right. Now, here, what is the rules I have given here? 20.1.1.1 should not ping 30.1.1.1. That too only echo request packet. What is echo request packet?
ICMP
ICMP
request packet.
request packet. What is opcode of that one? What is the opcode of the request packet? Wait, are you sure? What about reply then? Okay, come back. Echo request. Echo request. That means 20.1.1.1 should not ping 30.1.1.1. But if the 30.1.1.1 want to talk with the 20.1.1, it should ping. That means echo request should not come and reach the 30.1.1.1, but from the 30.1.1.1, it can reply back to the this one. What do you call 20.1.1.1? So on this one, 10.1.1.1 should not ping 30.1.1.2. So it's both what? Echo request and echo reply packet as well. Okay. So let's go. Now tell me on which route I have to implement this one. The first rule. 20.1.1.1 should not ping 30.1.1.1. Okay. So it should be done on the second router. So enable config C access list in this time. This time, what happened?
It's 8 only.
It's 8 only. I asked the next one. 3, right? Did you check? Okay, now this time I want to go for what? Extended. Okay. So extended, the number will be, I'm gonna take it as a 100. Next, if I say question mark, it's the same deny packet I have to give. If I say question mark, now a lot of information we have here. Okay. So as I already said you, it can understand different services. Okay. Now, let me show you this list. You can note it down if you want. So these are the list. Whenever you're going to deny or permit some particular or specific, what do you call, services, HTTP, Telnet, FTP, and SMTP. So these all comes under the TCP. Okay, DNS, EFTP, and DSCP and NTP, they all comes under the UDP, and ping and traceroute, they comes under what? ICMP. Okay, so what all the things you can see here? AHP, Authentication Header Protocol, EIGRP, ESP, GRE, and then ICMP, IP, OSPF, TCP, and UDP. Okay, so whenever you are choosing these protocols, you have to be very cautious. Okay, now I said ping. So where I have to go? I have to choose the ICMP. Okay, if I say question mark again, it says again the same thing. You want to deny the whole network or one particular host or any. Okay, so I'll just say one particular host. Why? Because as I said here, what I said, only 20.1.1.1 should not ping 30.1.1.1. Okay, so this is a source IP address. Okay, so here 20.1.1.1. Okay, if I say question mark again, what is the destination IP address? You want to stop this one. Did we have this in a standard one? No. This is only possible in the extended, where we can give both source and destination addresses here. Okay, so again, that is also one particular host only. Okay, if you don't want to go for the host, in that case, what you have to go? You have to go for the wildcard mask here. Okay, so let me show you. Later, I'll show it. Okay, now just see this one where I have to stop this one on 30.1.1.1. If I say question mark again, it will be giving me some different things. What are those? You want to do only echo or echo reply or host unreachable or network unreachable, port unreachable. So all these kind of things we have. Okay, so now I want to do it only for the echo request packet. So that is, I'm going to give only echo here. Okay, so let me drag this bit side. Yeah, just say enter. This is one deny rule. Yes, and I have to write two permit rules. Why? One is for the reply and one is for any traffic. Okay, so permit, sorry, 100 permit ICMP host 20.1.1 to the host 30.1.1.1, and it should get the echo reply. Okay, should get what? Echo reply packet. And one more, access list 100 permit IP any. Okay, so this is what how to write the extended rules here. Clear? Great. Now tell me the interface. Tell me the interface. On which interface we have to implement this one? 0/? Sure. It should be in or out? Outbound. Sure. Sure. Inbound. Murali. Inbound. Outbound. You also said outbound. Yes. Outbound. Inbound. Inbound. In out. Bound. Bound. Out. Out. Guys, I already said you, and again I'll tell you, the traffic is going towards the router. So that is called as what? Inbound. If the traffic is going farther the router, that is called as what? Outbound. So how come it will be outbound? Inbound, right? Here the traffic is going from 20.1.1.1 towards what? 30.1.1.1. Okay. If I do it on this interface, what will happen? The full network will be denying on this router 3. Okay. So that is the reason I have to do it here only. Understood? So this will be the inbound interface, not the outbound, where it is getting inside the router. Clear? Let's do that. On which interface? On interface giga/1, and it should be IP access group 100, and then it should be the in interface. Done. Here. Great. Let's go to this one now. On which route I have to do that? 10.1.1.1 should not ping 30.1.1.2. On which router? First router. Okay. And great. So enable and then config T. Access group, sorry, access list 100 and then just say deny. After that, sure. Host, are you sure? Who is gonna check the protocol? And then now, host, which host? 10.1.1.1 and then destination host is okay. And then echo and then echo reply also, right? Just say enter and one more is echo reply as well. Okay, enter. And next I have to give the permit list. Permit IP any. Done. Correct. Now tell me the interface. 0/0 should be. Sure. Are you sure? The interface gigabit than 0/0 should be IP access group 100 inbound. Done. Great. So let us check that one now. So I have to go on the, if I say ping says that I'm pinging. Why? Huh? I blocked what? Guys, I'm on I'm on 20.1.1.2. Okay. I thought someone will see that one, but nobody. Yes. Now this time, if I say ping 30.1.1.1, it says that destination host is unreachable. If I try to ping 2, it says that I'm pinging. So here host to host is possible, but that is not possible in the standard one. Okay. If you check with the 10, that will also ping. Okay. Yeah. Now what I'll do, I'll just go on 30.1.1.1 and ping 20.1.1.1. Do you think it's gonna ping? Yes? No? Yes? No? It will ping. Why? I said only echo request packet is denied, but not the echo reply packet. Okay, that is the reason it is pinging here. So if you check it on 10.1.1.1 should not ping what? 30.1.1.2. So in 2 it is. So before that, let me show you 1 also. 1 will be pinging. Okay. But this time it is a 2. So it will not ping. Okay. Even though if you go on this one, 30.1.1.2, if I say ping home, 1, it says that request timed out. Okay. That means here I have denied the both. Okay. Great. Any question in numbered extended ACL? Any question? No? Okay. Now, if no, then I will go for the named one. So, wait. Okay. And no access list 100. That's it. And one more. I've done it on the first router, right? So here just say okay. Now the same thing I'm gonna take here. The same rules what I have. Yes. So let's go. And this time, if you want to go for the named ACL, you have to say IP access list. Okay. If you say just access list, it will go for the numbered one. And if you say IP access list, it will go for the named one. You can see here. If I say question mark, it is asking me extended or standard. It is not asking me for any number. It is directly asking me for what? Extended or standard. Now this time if I say, I'm gonna say it as a standard, and if I say question mark again, so it is asking me, you want to give it a number or you want to give it a word here. So we already used a number, so now we'll give it as a word as a Cisco. Okay, and just say enter. Next, if I say question mark, it says that. One more thing you can see here. Configure standard NACL. That means named ACL here. Okay, so before what you used to see, it was just a config here. Config if. Yes. So now this time it says that what? Config standard named ACL. Yeah. Now you have to give what? Deny first. So deny. That's a question mark. Again the same thing. So this time it is a host. Which host? Sorry. On which router I'm in? Should be done on the. Should be done on third, right? So exit. Just say no IP access list standard. Cisco. Let's go on the third one, because standard will always run on the then on destination. Okay. So config T and then just say IP access list standard Cisco. Okay. And just say deny a host that is called 30.1.1.1. Okay. Nothing is there, just enter, just permit any. That's done. It's very simple. Again, the interface will tell me the interface. Again, it's wrong, right? I was correct initially. Yes, I have to do it on first router only. Yes, 30.1.1.1 should not ping 10.1.1.1. I was correct here. You guys confused me. It's okay, already there. standard and just say deny a host. Am I correct this time? Sure. So permit any again exit interface gigabit ethernet 0/0, and it should be IP access group standard. Sorry, this is Cisco, and then it should be out. That's it. Okay. And for the first one, 20.1.1.2 should not ping 30.1.1.2. So this should be done at the this end. So this will be like again IP access is standard Cisco, and you can say deny what? After that, you just need to say permit any. That's it. And interface gigabit ethernet 0/1. It should be IP access group Cisco, and then it should be out. Great. So let's check it immediately because still I have to cover one more. 30.1.1.1 should not ping 10.1.1.1. It says that destination host is unreusable. Even if you go with the 10.1.1.2 also, it says that destination host is unreachable. If you go with the 20, says that I'm pinging. Okay. So let's go on the second one. 20.1.1.2 should not ping 30.1.1.2. So the whole 30 network will be denied here. Okay. So if we go with the 10 network, it says that I'm pinging. Yes. Okay. Next, what I'm gonna do, let me show you to show access list. How many you can see here? 2. Okay. Now I want to add one more in between here. I want to add one more in between. So that will be the one more deny. Yes. So how to do that one? Just need to say IP access list standard Cisco. Okay. And if you say 15 deny whatever the one, tell me deny what? 20.1.1.1. Okay. That's it. If you say do show access again, you can see that. Is it added between? In between. Yes. The thing is like in numbered, it is not possible. In named, it is possible. The thing is like you have to use the only number here. Okay. Whatever the number in between these two, you want to add in between there. Okay. You just need to use a number in between that one. Okay. And if you want to delete this one, the same thing you have to do. What is that? IP access list standard Cisco. Okay. And if you say no 15, that will be done. If you check it again, do show access list, it goes. Okay. This is how it is possible in the named ACL. Clear? Named ACL, not number. Okay. Am I clear? Yes. Okay. So just say now no IP access list standard Cisco. Okay. On which interface I have given here? On interface gigabit is plus 0, and here it should be no IP access group Cisco. What? Out. So on this one also, I have to remove this one. So just say no here, and that's done. Exit and no IP access list. Already removed that. Standard Cisco. Okay. Yeah, that's done. Great. So let's go to for the second one now. What is that? 20.1.1.1 should not ping the 30.1.1.1. On which router? Middle router. Okay. So this time if you have to say IP access list and this time extend it. Okay. And again, you can give the Cisco only. Just enter and this time deny. And if I say question mark, it will be giving some again. The services what it is supporting here. So it is a ICMP and one host. That is what? The host is 20.1.1.1. 20.1.1.1 and the destination host is 30.1.1.1. Okay, and the tick, that is it. And next I have to give what? Permit ICMP host 20.1.1.1 to the host 30.1.1.1 and that should be echo reply packet. And one more thing, permit IP any. Done. Clear? Okay, great. So exit from this one, interface gigabit Ethernet. Which one? 0/1 it should be. Exactly. IP access group Cisco in it is. Great, good. So let's go to the second one, 10.1.1.1 should not ping, 30.1.1.2. On which router? First router. This time you have to say IP access list extended. And in that case, it should be again Cisco and then hit enter. And then after that, just say deny. Deny what? One particular host, sorry, deny ICMP host 10.1.1.1 to the host 30.1.1.2. Okay. Then you have both echo and echo reply packet as well. After this, I have to permit IP any and then exit from this one. Interface gigabit Ethernet 0/0 and this should be IP access group Cisco and then it should be in. I hope everybody got what I have done. Yes. So let us check that. Yeah, first thing 20.1.1.1 should not ping. Pinging with 10. Yes. Pinging with 30.1.1.2. But it's not ping. It says destination host is unreachable. Okay. Let's check with the 30.1.1.1. Is it pinging 20.1.1.1? Yes, it is. Okay, it says that I am able to ping. Yes. So let's go on the second one. 10.1.1.1 should not ping. Two. Says that destination host is unreachable. Even if you do on the other end, says that destination host is unreachable. Okay. Am I clear? So here also you can add or delete the statement in between. Okay, one particular statement from that ACL. Okay. Yeah. Any doubt here? No. Okay. 20. PDPLL page done. Okay. Okay, we'll take some of the theoretical parts. Yes. VPN is done. It is. We'll do that. That is a practical part again now. Okay, we'll see something about the APs. Cisco wireless architecture. Okay, how we can design the Cisco wireless architecture. So Cisco wireless solutions provide some scalable and robust architecture for wireless network deployments. Okay, I mean, if they ask you like, we'll be having the Cisco's APs. APs means what? Access point. Okay, so how we can deploy that one? How we can design that one? Yes. So these architectures include some centralized or distributed, enabling organization to design network based on their specific requirement. Okay, in that first one, centralized wireless architecture. What is this? Centralized wireless architecture means what? Here we need the WLC, wireless LAN controller. Okay, so in this architecture, wireless networks are centrally managed by the wireless LAN controller. In short, we call it as what? WLC. That means he is kind of a manager, and all the APs, they are kind of a team members. So all these team members will be reporting to the WLC, and however he wants, they will be working with that. Okay, and if he want to pass any kind of a message, he has to go and meet the WLC, and WLC will send the same message to everyone at the same time, because all of them, they will be centralized under the centralized management. Okay, so some components here they need: wireless LAN controller, that's nothing but the WLC, and then manages this wireless LAN controller will manages all the access points centrally. Okay, and then it handles a task like what? Authentication, roaming, and radio frequency management as well. Okay, the total control will be under the WLC. Yes. And next is lightweight access points, that nothing but are access point only. So here it operate in a lightweight mode and rely on the WLC for configuration and the management. Every configuration and the management will be done through what? WLC. Okay, so here to establish a cap map, control and provisioning of a wireless points, access points, tunnel to the WLC for communication purpose. I mean, every time if they want to talk with anyone, they have to go through what? WLC first, and then they can able to talk with someone else. So next is like, what are the advantages of having this centralized wireless? So it is simplified management through the centralized controller. Okay, I mean, if you want to pass any kind of a same policy to all those lightweight access points, okay, we just need to do it on from that centralized controller. Okay, the same will be done on all the devices. So consistent policies and configuration across all the APs, and advanced features like what? Radio frequency optimization and seamless layer 3 roaming. So this is supported in the centralized wireless architecture. Okay, so this is used in a large campus or enterprise where centralized management is totally critical. Okay, let's suppose the same, I think I have given the example. Let's suppose you have a company. In that company you have some 40 to 50 APs. So is that easy to maintain all of them at the same time? No. Okay, so that's the reason what they will do. They'll take a WLC, a centralized controller, and they'll make all of them into a under this WLC, and they will be really easy to control now. Yes. So this is what the centralized controller. Next is what? Distributed wireless architecture. Distributed wireless architecture. So in this architecture, access points operate independently without requiring constant communication with the WLC. So it is totally independent. Yes. So access points will be operating itself. It doesn't have any kind of a centralized controller. Okay, in which situation you can see in a small offices or a branch location with a minimal AP requirement. In this case, we don't need to have any kind of a WLC, a centralized controller. Okay, so here it is autonomous access point like functions as a standalone device running their own configuration and managing wireless clients independently. Here it doesn't need to report to the WLC. Okay, they will be working standalone independently. Yes. So here no dependency on the centralized controller, and it is totally ideal for what? A small or a remote deployment where a centralized management is totally unnecessary. Okay, for example, this is a one floor. In this, we can have one or two APs. So why to have the centralized controller just for one or two APs? Okay, so this is called as what? Distributed wireless architecture. Yes. So next is cloud managed wireless architecture. So what do you mean by cloud? What do you mean by cloud? Database? Server?
It's for
Mhm.
our company is
Mhm.
storage and virtual data.
Okay. So infra will use someone else's. Okay, we'll be using it as ours. Just it was just as a renting. We'll be taking a rent of all those devices and we will be using for our use. Okay, our purpose. Yes. So cloud managed wireless architecture. So in this architecture, access points are managed via cloud-based controller. Okay, eliminating the need for what? On-premises WLC. Let's suppose I have a big firm. Okay, and my what do you call my headquarters is in Bengaluru, and I have some branch offices in some Pune, Delhi, or somewhere else. Okay, and there also have some what do you call APs, access points. Okay, and what I'll do, I'm not going to buy the separate WLCs for each and every branch. What I'm going to do, I'm going to take a single cloud-based controller. Okay, so that will be controlling all of these APs in a cloud managed system. Okay, so here the thing is like we don't need to have a on-premise WLC. We can take a rent of that cloud-based management WLC. Okay, and they will be maintaining everything. What I have to do, I have to just pay them. Okay, whatever we use, that much. So here the first thing you need, that what? The cloud dashboard. It is very important, like a centralized platform hosted in a cloud for managing and monitoring the APs. Okay, this is where you monitor and manage all these APs in a centralized way again, and communicate directly with the cloud controller for the management and update. Here we don't have any on-premises WLC. Here directly they will talk with what? Cloud-based management. But the thing is like they have to be in the, I mean, they have to use what? Internet. Then only they will be able to communicate. Okay. So what is the advantage of this cloud-based management? So it is easy scalability and deployment. Yeah, easily you can deploy it anywhere. Okay. Just the thing is like you have to add it into the cloud management. Next, reduce the hardware and maintenance cost. Why? Because I already said you here you don't need any on-premise WLC. So obviously it is going to save you a lot of money here. Yes. And the centralized management for geographically dispersed network. For example, what? Multi-site organization like what? Retail chains or educational institutes. If you have multiple educational institutes in a different area or different cities, in this case you can take this service, that is cloud managed wireless architecture. Okay. So the fourth one and the last one is what? Controller-less or wireless architecture. Okay. Here, a Cisco also offers what? Solutions like what? Mobility Express, where one AP acts as a virtual controller. I mean, you'll be having this lightweight access points. So among this, one will be elected as what? WLC, where from that one only we are going to control all the other APs here. Yes. So that is called as what? master access point. Okay, so to this master access point only, all the other subordinate access points will be reporting. Yes. So it acts as a controller for managing other access points, and subordinate access points, they will be operate under the master AP's control. Okay. And what is the advantage of having this one? Cost-effective solution for small to medium network and simplified deployment without any dedicated WLC. Here also we don't need any kind of a dedicated WLC. So under the same master AP only, we are going to operate all the other subordinate access points. Okay. So here it is used in small to medium sized businesses or a branch offices as well. Okay. Okay. Next, we'll see what are the modes of this Cisco APs. First one, local mode. So local mode means what? It's a default mode for lightweight APs where it's going to handle the whole traffic of the wireless clients. Wireless client means what? Your laptop, your PCs, or it may be your wireless, mobile phones or tablets. All these kind of things are called what? Wireless clients. So where you connect exactly to the access point. Through that, you are going to connect to the internet. Okay. So that mode is called as what? Local mode, where it's going to handle the client traffic locally, but forwarded the traffic towards the controller. That is nothing but the WLC. So we can see these kind of things in the campus deployments where a centralized management is necessary. Next is flux mode. So here it enables the APs to switch client traffic to locally when the WLC is totally unavailable. Okay. I mean, if a WLC stopped working, if you are keeping that particular AP in a flex mode, then immediately it will switch it over to the WLC. Okay. It is ideal for what? Remote sites with a intermittent WAN connectivity to the WLC. You can use it in a branch offices with a WAN latency or a outages of the WLC here. Okay. Next we have monitor mode. The name itself will tell you what it does. It will monitor the other APs. So APs do not serve the clients but monitor the radio frequency environment for interference or a rogue APs or other anomalies. What it's going to do? It's not going to serve any kind of a wireless clients like what? PCs or laptop or a mobile phone. They are not going to connect those devices to the internet, but they will be monitoring everyone. For what? For rogue APs, I mean the malicious APs or something, or any other anomalies which is happening in the network. Okay. So this is for a wireless security and spectrum analysis. Next is a sniffer mode. Here APs capture wireless packets and send it towards the network analyzer like what? Wireshark. So here also it doesn't serve the wireless clients. They'll be just capturing all the packets and they will be sending it towards a Wireshark. Okay, for analysis purpose. For troubleshooting and analysis purpose, it's going to send those wireless traffic towards a analyzer. Okay, just like what? Wireshark. Next is rogue detector mode. Here it focuses on detecting rogue devices by monitoring wired and wireless traffic. Just to enhance the wireless security in environment to prone to the rogue devices, we are keeping the AP mode in a rogue detector mode. Clear? After that, we have bridge mode and a mesh mode. So bridge, here APs operate as a wireless bridge connecting two physically separate LANs. So where you can use this one? Connecting remote buildings or extending the network over a wireless. Let's suppose like we have two buildings here. Okay. And here wired connection is not possible. Okay. In that case, what we can do? We can connect one AP here and we can connect one more AP here. So this If you make them as a bridge mode, then they will be connecting these two networks here. Okay. So last one is what? Mesh mode. That is also kind of the same. So here APs of form a wireless mesh with one or more root APs connected to the wired network and other acting as a mesh node. Okay. So outdoor environments or a location where cabling is impractical, in that case, you can use this mesh mode where it will allow the other clients to connect with the internet. Okay. So this is something about the architecture of the Cisco APs. Okay. Triple A is also done, right? Wireless.
Light
Light hodo.
next class
IPv6. I think we're done, right? We're done with routing also. I hope you know this, right? Yes. Interface A version is just like 0, and then the IP version 6 address will be 2000 colon db8 double colon 10 slash value 64. Just say no, shut it down, and after that IP version 6 enable. Okay, and exit, and unicast routing. IP version 6 unicast routing enabled on this one, and interface gigabit connect 0/1, and here the IP version 6 address will be 2000 colon db 8 double colon 1 with a slash value 64. Yes and no shutdown, and IP version 6 enable and exit. That's already done. Okay, so let's go to the second one. CLI, and here no. Enable interface gigabit then just like 0, and here IP version 6 address is what? 2000 dba double colon 2 with a slash value 64. Okay, and just say no shutdown, and then IP version 6 enable and exit from this IP version 6 unicast routing. That's done. And interface gigabit connect 0/1, and then IP version 6 address, that is 2000 colon db9 double colon 10 with a slash value 64, and complete. ಯಾವಾಗ ಅವನು one, and then this IP version 6 enable done. If we say do show IP version 6 route, it shows you what the IP address 2000 is there, db9 and then db8, two networks. Okay, so it is a statically connected. So now do you think both are going to ping now? Sure. For sure it's gonna ping to this 2000. Let me write this 2000 db8 double colon with a slash value 64 here. Okay, and then here this side 2000 colon db9 double colon with a slash value 64, and between these two 2000 colon dba double colon slash 64 is the network we have here. Okay, now tell me, if I try to ping from this PC to this PC, is it gonna ping? And how come yes? So ping 2000 colon db9 double colon 1. What it is? Where it is dropping? Where it is dropping? Where it is dropping? You can see here, right? db8 double colon 10. What is this? It's the gateway, right? Why it is dropping? Because it says that I don't have this db9 network. If you just check it here, I think you forgot the routing, right? Do show IP version 6 route. Okay, statically I didn't added anything. Yes, you can see. Can you find any? Here db8 is there and dba is there. These are directly connected route. Okay, what we have to do? We have to add one array static. So again IP version 6 route. Okay, and then 2000 colon db9 double colon with a slash value 64. The next hop will be 2000 colon dba double colon 2. Okay, that's it. I have added one root here. Okay, if you want to check that one, there it goes. Yes, yes, is there? Statical assigned one. Which one? DB9 network. Now this time if you just try to ping that one, should. Did I enable routing there? ಏನು ಕೇಳೋದೇನೋ? Just try to trace 2000 DB9 double colon 1. It's not going out of the network. That means I think I did right. I said unicast routing here to show run. Yeah, IP6 unicast routing is there. Anything else? IP6 enabled. Okay. On this one, to show running configuration. Yeah. Even here also I said IP6 unicast routing. On the interface, did I enable this one? Yeah, I did. Why it is not? Why it is not switching? Yeah. Now this router doesn't know who is this DB8. Okay. With you, I'm also forgetting the IP6 route. So that is 2000 DB8 class 64, and this should be reachable via 2000 colon DBA double colon 1. That's it. Okay. If you check, do show IP version 6 route, it will show you one statically added route. What is that? DB8. Okay, via it is reachable DBA double colon 1. So now this time it has to ping. There you go. Yes. So if you want to ping, it says that you're signed on. Done. Clear. And in that same, I have given default also. Okay. Network routing, host routing, and even flow text static routing also. Okay. The simple thing is like you just need to, instead of IP version 4 addresses, you have to give the IP version 6 addresses. The process is everything is same. Okay. And this is advanced kind of configuration. This you don't have in the CCNA. Yes, you have in the advanced, not only in routing, advanced routing. There you have this IP version 6 routing there. Okay, there again you are going to learn. So for now it is enough. Same protocol but advanced of this. Okay. Yeah. Any question? Any question? Any question? Done routing? Done. And do one thing, on actual devices also just practice IP version 6. Okay. One more thing. Virtualization. Cisco based on either channel FTP key security concept. Okay, we'll see some key security concept, and one more is there. So we'll finish that, and we'll be remaining with only 3 to 4. Donut automation, quality of service. Again, it takes 2 days. Okay. You want to? Yeah. So understanding the core principle of security threats or vulnerabilities and exploits and mitigation techniques is really important or essential to protect the system or network or the data. I hope you know that nowadays data is more worthy than the gold, I can say. Yes, am I right? Data is really worthy than the gold. So to protect this one, okay, we have to take all the essential, what do you call, techniques, whatever we have to adapt. Okay. So before that one, what are the different vulnerabilities we have, how they may get exploited. So everything you should know that one. So that first one is a threat. What do you mean by threat according to you? What do you mean by threat? Exploitation. Okay. Okay. Threat means what? It's kind of a danger. Okay. So it's a potential danger that can exploit a vulnerability to cause harm or damage to a asset. In our case, what is the asset? Data. Our devices, our data, our network. Okay, so these are our assets. Okay, so how to protect all of them? Okay, so this has to be done in the, what do you call, learned in this year. Okay, first one, you can have different types of threats. First one is what? Natural threat. So because of some earthquake or a floods or fires, so because of that also your assets will be get damaged. Okay, next is human induced threats. So what is this one? In that also we have some two types, intentional and unintentional. Okay, so hacking, malware and phishing, so this comes under the intentional threats, and unintentional like a human errors or a misconfiguration which will lead to the what? Threats. Okay, so the second one, the third one, that's nothing but the environmental threats, just like what? Power outage or a hardware failure. So this will also lead to the threat to the devices like data or a system or a network. So for example, an attacker attempting to gain unauthorized access to a system. Okay, so an attacker like him, okay, he is trying to get the unauthorized access to the network. So that is kind of a what? Threat to the network or a device. Yes. So if you are having threats, then it will be vulnerable. Vulnerable means what? It's kind of a weakness or a flaw in the network. Okay. Vulnerability is nothing but what is a weakness or a flaw in the system or software or a network that can be exploited by a threat to gain unauthorized access or a cause harm. Okay. This all kind of things is what? Just a way of earning a lot of money. What is this? What the attacker will do? What he will do? Will just take the unauthorized access to any kind of a system and he will try to blackmail you. He'll try to blackmail you. See, this is what the data I have of your personal data. Okay, so I can able to exploit this one. if you don't give this much and that's that and blah blah, whatever it may be. Okay. So what is this? What are the example of this vulnerability? So some in cases outdated software with unpatched security holes, this may lead to what? Vulnerable. It's kind of a weakness to the network or a device. Okay. I mean, I hope you know that this firewalls always they will be what do you call updating every month or every 15 days in an actual network. Okay, what they will do? They will always update those firewalls because every day young minds or attackers like you, every day they are sitting on the internet. They will be finding a different way to hack your system. Okay, so to that, whatever the update or a patch they will give you, you have to update on your system. Otherwise, it is vulnerable. It is a kind of a flaw in your system. Okay. So even weak passwords or misconfigured access controls also lead to what? Vulnerability. And even the lack of encryption for sensitive data or a poorly configured firewalls or network devices, they may lead to what? Vulnerable or exploit the device. Okay. A web application using the outdated software with a known security bugs, it's kind of what? It's a weakness of that one. Yes. So attacker like you can exploit that one. Yes. Next is what? Exploit. What is exploitation? What is exploitation? It is a technique or a specific technique or a code that take advantage of vulnerability to carry out a attack or achieve unauthorized result. Okay. So your system is having some weaknesses or vulnerability. So what he can do? Always will be finding that one. Yes. If he get through your system, he'll be able to access all your data. Yes, he'll be getting all your data, and what he will do? He'll just try to blackmail you. Okay. So same thing here also will happen. First one is what? Zero day exploitation, like targets a vulnerability that is unknown to the vendor and has no available fix. I hope you heard about the bug bounting and this all things like bug bounting. Do you know? So what is that? Bug bounties. They will be always finding some vulnerability in the system. Okay, even if I have my own software. Okay, what I will do? I'll just hire a bug bounty. Yes, I'll give him my software and I'll try to. I'll tell him try to find any bugs. Okay, the complete bugs is already cleared, but still, if you find any, please let us know. And if he finds the bug, and he will be knowing the fix for that one. Understood? So he can ask a lot of money for that one. Okay, so that's the reason a bug bounting is really important. Why? So a lot of people will be doing the same thing. They will be continuously working on the same bug bounting, even on the Windows or Microsoft, whatever they're having. Okay, they will be continuously working on that one. If they find a small bug, okay, and for that they will be having a fix, so they can ask a lot of money to the vendor. Yes. So if the vendor try to fix that one, he doesn't know the fix for that one. Okay, only the attacker knows. Only the bug bounty knows that one. Yes. So that's the importance of this bug bounties. He can exploit any system. Okay, if he finds any bugs in the system. Yeah. So next is what? Software exploit, like target flaws in the application or operating system. That's what I said. And after this he go for the social engineering. What is social engineering? He is going to manipulate the individual to disclose sensitive information. Okay, for example, if you just click any kind of a phishing link, okay, so it may lead to again your data leakage. Yes, what will happen? The attacker will call you. Okay, yeah, this is what the data, your sensitive data I have. Okay, and if you don't send this much of money, I'll just send it to everyone. I'll just make it as viral. Okay, so that is called as what? Social engineering. What is social engineering? Manipulating a individual. What is that? Manipulating the individual just to disclose their sensitive data. Okay, so that is called as what? Social engineering exploitation. And then after that, hardware exploit, like some hardware also they will be having their flaws. So target physical devices or firmware and he can find some bugs in that one. Okay. For example, an attacker using the SQL injection exploit to manipulate a database. Okay, I hope you know that SQL is used for what? Database management. Yes? Yeah. So after this, after exploitation or vulnerability, we have to have some mitigation techniques, right? So how we can mitigate this? Mitigate means what? Solve this one. Okay. So mitigation refers to the strategies or tools or practices used to reduce the risk of the threats exploiting vulnerabilities. Okay. So these are some techniques that are used to mitigate the exploitation or vulnerability. First one is what? Patching and updates. Why your system or mobile vendor, they will always or continuously or frequently, they will give the updates. Why they will do that? Just for the security purpose. Okay. So regularly update the software or operating system and firmware to fix some known vulnerabilities. Okay. After that, access control, like implement least privilege or a strong password policies and multi-factor authentication on your system. So like this also you can mitigate the exploitation or a vulnerability. Next, you can connect with the strong firewalls or IPS or IDS. So do you know what is IPS and IDS? What is that? Intrusion detection and intrusion prevention system. Okay, what is detection and prevention? If any attacker unauthorizedly trying to intrude in our network, intrude means what? Unauthorizedly take the access of our system. Okay, these systems or these devices, they are going to check that one. They'll be doing the same thing with the help of some algorithm. That again configuration is something different for that firewalls and IDS and IPS. Okay, with the help of that one, if you go only with the intrusion detection, it will just detect you. It is not going to prevent that one. So prevention is nothing about, it will detect and prevent also. Okay, so these are the two systems, and even we have firewall also. We can, what we do? What is firewall? It will be filtering or monitoring all the incoming and outgoing data. Okay. So you can use the firewalls and the intrusion detection and prevention system to monitor and block the malicious traffic. After that, you have to encrypt, like sensitive data should be encrypted during the transit or even at the rest also. Okay. And everybody should be trained about this. Basically, nowadays everybody are using the mobiles. Okay. And some people, the sorry, yeah, the old people, they don't know what is this link and all. If I click on this one, okay, this may go somewhere. Yes. So everybody should be have a actual or particular training on that. Okay. So educate users on recognizing phishing attempts and practicing a good security hygiene. Okay. And after that, network segmentation should be done like what? Separate the critical assets from general network traffic to limit the exposure. Okay. So for example, you'll be having a server, okay, where you'll be storing our sensitive data. Okay. So this network should be really but segmented. So other than our normal network. So this kind of network segment should be very good for the security purpose. Next is what? Backup and recovery, like maintain the regular backup and recover from the ransomware or data loss. And next, last, you can go for the incident response plan, like develop and test a plan to respond to a security incident quickly. Okay. So these are what? Just for the key security concepts, what we use with the data, device, or the network. Yeah. And one more we have, that will be like virtualization fundamentals. What do you mean by virtualization? Any idea? Virtualization. Sorry? Creating virtual environment. Okay. Yes. No. Have you heard about virtual machines? Have you used hypervisor on your system? You did? Why it is used for? Exactly. Running different operating system on a same physical one. Okay. If you check with the hypervisor, so yeah, there it is. It will allow me to use the same physical system to create one more virtual machine inside this one. Okay. It's kind of what? Computer inside a computer. Okay, where it can have its own RAM. I mean, not own RAM, it will be using the same physical CPUs, physical RAM, physical SSD, everything, but it will be operating independently. Understood? So it may have its own operating system as well. It will be having its own a network, what do you call, adapter as well. Everything will be different. That is called, we call it as what? Virtual machine. It's not a physical one, but it is behaving as what? A separate computer. Okay, so here it will allow you to create a virtual machine here. Okay, if you go here in new, okay, I'm not going to show that one. Here it is, virtual machine. Okay, we click on that one, which will allow you to go and give the different name for that one, and then you have to give the generation and everything is there. Okay, if you want, you can do it later. Okay, are you using for Linux? Which one? Yeah, that is a separate tool we have. Okay, just for example, I said this one. Okay. Yeah, what is virtualization? It's a process of creating a virtual version of a physical resource, such as a server, network, or a storage, allowing multiple instances, environments to run on a single physical hardware system. What will happen here? If you go with the servers, what the server will do? They will allow us to create some multiple, what do you call, what is server exactly? What is server? It is basically used for what? Store the data, and which will serve the clients. Whatever he is asking for, he's going to give the reply for that one. Okay. But the thing is, like, he has to have that data inside it. Okay. The server is kind of what? It's kind of a separate computer where it will be having a stack of hard disks. Okay. It's a stack of what? Hard disk. And to control all of them, they will be having a one CPU. Okay, and even the RAM also, it will be having everything just like our system. Okay, so what we'll be doing, we'll be creating some separate virtual machine inside that one. Yes, and inside that we are going to install a different operating system. It may be Linux, it may be a Windows, it may be any other. Okay, so what they will do, they will allow us to virtualize this network or a storage or a computer system. Okay, on a same physical hardware. Okay, so it increases the resource utilization and flexibility and even the scalability. Okay, so first one, server virtualization. The same thing I said to you, server virtualization. So it involves partitioning a physical server into some multiple virtual server. Okay, where each is running its with own operating system and even the application. Why we virtualize this one? Just to run our separate applications on that one. Okay. So first one, I mean, some key concepts of this one. The same hypervisor I have shown you now. The software layer that enables the server virtualization by abstracting the hardware. What it will do? It will take or abstract the same physical hardware system what we have here. Okay. So it may be CPU, it may be RAM, it may be the hard disk. Okay, everything will be taken from the physical, but it will be created in a separate way as a virtual machine. So that can be done in a two ways. First one is a type 1 or type 2. First one is a bare metal, or the second one is a post-it. So what is bare metal? It runs directly on the physical hardware. For example, VMware ESXi or Microsoft Hyper-V and then Xen. So all these what? These are the tools which will be directly running on the physical hardware. Now, what is the type 2 hosted means what? It runs on the host operating system like a VMware workstation or Oracle or VirtualBox. So it will be done on the server devices, which will be running on the server, okay, where you are hosting your own application with a different operating system. Okay. So those are called as what? Virtual machines. So it is independent operating system instances that run on the virtualized environment where they will be taking the help of the physical CPU, memory, storage, and the network interface also. But it will be dedicatedly given to the virtual machine there. Okay. So this amount of the RAM will be given to this virtual machine. This amount of RAM will be given to the second virtual machine, like that. Understood? So what are the benefits of this one? It is efficient resource utilization, like maximizing the usage of CPU, memory, and storage by running multiple workloads on the same hardware. Okay. So now barely like some 5 to 6% of CPU is utilizing now. My system I'm talking about. And again 5 to 6% of the RAM, and then again 5 to 6% of the storage will be utilized. What is the use of the remaining 95%? So we can give it to the virtual machine. Understood? So isolation, each VM operates independently, reducing the impact of the failure or security breaches in the other VMs. Yeah, obviously, if you create some different virtual machine on a single system or a physical system, if the security breach happens at one virtual machine, it's not going to go, it's not going to affect the other virtual machine. So they will be totally independent. They will be totally isolated with one another. Yes. And scalability, it is easily add or remove some VMs on demand changes. Okay. Where you can use this one? In a data center consolidation or a testing and development environment, or even in the disaster recovery solution. Okay. So this is something about the server virtualization. Next, we have containers and VRF. What is container? Do you know container? Yes. Does anybody know Kubernetes? No. Okay. Container is nothing but it is a lightweight and a portable unit that encapsulate an application and its dependence allow it to run consistently across environment. In a short words, what we have seen in the virtual machine? What is in the virtual machine? Here, every virtual machine will be having their own operating system. They will be having their own CPU, RAM and the storage also. But here in the container, here it will be having only one operating system. So on behalf of the same operating system, every different containers will be running. Okay. So let's suppose I have a hard disk. Inside that one, I'm hosting my application. Okay. So this is not having its own operating system. It will be using the same, what do you call, the container engines operating system. You can see the same different components of this one. First one is a container engine. So that is a software that manages the containers, just like what? Docker or Podman. I hope you heard about the Docker and Kubernetes and all, right? You heard it, the words? No? So container orchestration, like tools for managing large scale containers deployment, like Kubernetes or Docker Swarm. Okay. So these are the tools just to manage all these containers. Okay. So what is the difference between with this containers and the VMs? You can see here, containers share the host operating kernel. Unlike what? Unlike that require a separate operating system in the VM. What you are seeing in the VM? Each and every virtual machine, they will be having the separate operating system. But here in the container, they'll be sharing the same containers, host operating system kernel. Okay. And containers are smaller and faster to start than the virtual machine. Why? Here in the containers, we have only single operating system. If that turns or booted in, that's it. So here the different containers, they don't have their own operating system. But when it comes to virtual machine, they have their own operating system. There it may take some more time there. Yes. So what are the benefits of this one? Portability, like applications in the containers can run on any environment with a compatible container runtime, and efficient, minimal overhead compared to the VM since they share the host operating system kernel. Okay. So that's the reason we can find the lowest overhead in the container as compared to the virtual machine. Okay. After that, consistency, it reduces the like it works on my system or machine problem by bundling dependencies with the application. Okay. And where we can use this one? You can use it in a microservices architecture. Okay, very small services architecture where you want to deploy your application, or a DevOps pipelines, or a cloud native applications. Okay. So last one is a VRF. This is related to networking. Okay. So what is this now? Here, VRF is nothing but virtual routing forwarding. Virtual routing forwarding. So how many routing table does a router maintains normally? How many routing table? Not like that. A best path will be having only one. So routers only maintain only one routing table. But this VRF is gonna allow us to maintain the multiple routing table on a same device. Okay, we can have multiple routing tables. You can see VRF is a technology that allows multiple routing tables to exist simultaneously on the same physical router on a layer 3 switch. Router or a layer 3 switch, enabling logical network segregation. So what it does? So let's suppose we're having a router here, which is connected to some multiple companies. So what it will do? So it will allow us to have the same IP address to all these companies. Okay. So routing instances, each VRF has its own independent routing table. So isolation. So packet in one VRF cannot be routed to another VRF unless explicitly configured. With the use of some route leaking configuration, we can do that one. So what is the benefit of this one? So it will allow us to segmentation, like ideal for isolating different customers, departments, or a services in a shared infrastructure. Okay, if you're creating VRF1 here, VRF2, VRF3. Okay, so all these will allow us to have the same IP address. Okay, they can share the same IP address, but they are not going to share that data with the other network here. Understood? So overlapping IPs, it supports what? Overlapping IP addresses spaces without any confliction. That's what I said. It's not going to share one company's data to the other company. One VRF route to the other VRF route. Okay. So security, it is logical separation of a network traffic. Okay. It's not a physical one. It's a logical separation of the routes here. So where you can use this one? In a multi-tenant environments, for example, service providers hosting a multiple clients. For example, this is my ISP router. So on this one, multiple vendors are connected. So on this one, you can configure the VRF, virtual routing forwarding. Next is segmenting traffic in an enterprise network. For example, separating a production network or a development. So this kind of aggregation you can do, and it will help us in routing for the VPNs also. Okay. So this is something about the virtualization. Clear? Okay then. These four are remaining. So we will be done with the ACL. Okay, it may take tomorrow and day after tomorrow. So tomorrow we'll try to finish L2 security and then NAT and then the quality of service, because network automation is a very big topic. Okay. Two are practical and two are theoretical. Network automation and the quality of service, they are theoretical, and then remaining are practical. Okay. Okay, then we'll meet tomorrow at the same time. Till then.